Okay, so yesterday we have seen a few of the memory parameters and about PG bench. Okay, and we also seen about analyze and explain options whatever we have, and also we have seen about re-indexing and clustering, right? So today we will continue. We'll see some partitioning and how we can manage partitions with the help of PG part one, and we will also see how we can generate the AWR kind of report. Okay, and we'll see if any users get some of the requirement like to pull the data into CSV format or something, which is the best practice for pulling it with the copy command. Okay, so we'll see these scenarios today. Okay, so first what I will try to do. So
one question with reference to this yesterday you explained plan and all that, right? So like OEM, what is the equivalent for Postgres?
We don't have like OEM kind of thing. We have to go with some of the monitoring external tool like we have. So basically we monitor everything with the so everything with PG admin only. So actually we don't have like similar kind of OEM, but if you go with enterprise editions like EDP or if you go with any cloud vendors, okay, they will provide you monitoring metrics tools from console, but you don't have any kind of tool like similarly like OEM in Postgres.
Okay. Okay.
Yeah, we may integrate some third-party tools like AppD or some other tools, okay, to integrate for monitoring. But as Suresh said, like we don't have any separate tool like OEM. Okay, in the PG admin also, like you can see on the dashboard, it is going to give like almost every statistics, but it is limited. Okay, it is limited to give the statistics of what actually you're looking in the OEM. Okay, in PG admin we have a lot of limitations. Yeah, but we have some other third-party tools also. Like we can integrate those things and we can monitor the same.
Yeah, we have PG Badger. So those tools we have to to keep monitoring and all. Like if you want to get automatic alerts and all, we have to go with some tools.
Okay.
Yeah.
Sure.
Okay, so
Suresh, I have a question. So can we use this Prometheus, Grafana for Postgres? Are they being used for this database as well?
Sorry, can you come again? Percona?
No. This Grafana, Prometheus and all, are they, I mean, can we use them as well?
Yeah, we can. Yes, we can.
Okay.
Yeah, we can use anything actually. See, it is an open source, right? Whatever your organization, see, each organization will look for different tools, even extensions also. Okay, so it's based on our requirement. We can use any tool. Actually, no problem with that.
Okay.
Okay, so for example, I'm trying to just create two tables. I just want to show something like. Yeah, I have 3 records in this table. Okay, so let me create one more table. Okay, for example, I want something like this data, dot emp name and e dot employee name, and I want d dot department name. So to perform any join operations, actually we need to use these keywords like inner join, outer join, left outer join. In Oracle, we can also use some symbols, right? Less than or equal to great. So some symbols we can use to join inner join and outer join, but here we cannot, like equal to plus equal to something we will use in Oracle. So here we cannot, we have to use this keyword. E dot is the common column, employee name equal to D dot. Okay, so explain. I just want to fetch the execution plan for this query. Even I want to execute this query. I just not only need execution plan, but I also need to run this query. Okay, so here in this query, if you observe, okay, let me create an index because mm, yeah. So if you observe here, actually, since we don't have any index, actually it is it has to go with sequence scan. So here sequence scan is, it is kind of full table scan in Oracle. Okay, so don't confuse about this sequence scan. Sequence scan is a full scan. If it is using an index, basically it will give you as index. So index scan. Okay, so I will also try to create one more index on department table on same EMP. Okay, so let me try to take the execution plan. Okay, so even though I create an index, still it is going with full table scan, right? So it is not, because we are trying to fetch almost 99% of data from the table, right? So it is having only 3 records, but you are trying to fetch almost 2 records from the table. 2 records or 3 records? How many records we get? Yeah, 2 records from this table, right? Now, actually, optimizer will decides whether to go for full table scan or index scan, right, based on the stats it has. Okay, but few times what happens, your index may not used, even though you are not selecting almost 90% or 80% of data, you are just selecting 10% of data. Okay, so in that case, if you want to forcefully use this index, actually we have in Oracle we can use the hints, right? In hints you can also force to use this index, something kind of and even you can use some comments. So many hints options we have in Oracle, right? Here we don't have any hint option. If you want that, we have a separate extension, okay, to use the hints. But for now, there is no inbuilt, we don't have any hints. But to forcefully use this index, we have a parameter called um, enable sequence scan. Okay, so by default it is on. We should not off this. But for example, if you want to forcefully use the index for this particular query, okay, so I can forcefully make it off. Now let me execute this query. Okay, now if you see, it is trying to use the both indexes, right? So I'm forcefully trying to make to use of this index. So we can just make this a session level of. So whatever the indexes it has, it will go and use this index which I created, right? So you can just but optimizer will take care of, okay, whether it has to go with full table scan or index scan. But few times if you don't have latest stats up to date, even you can make it to use this index, okay, by making this parameter the session level off, and it will make it use of this indexes. Okay, optimizer will forcefully use this indexes. Okay, so this is something we can do. It is doable to forcefully use the index in Postgres by setting this parameter. So I'm making it on again. Okay, now it is going with, if you observe the execution time, okay, so this is more than this, right? So index, it is going something quick, even though it is having, we are trying to fetch most of the data from the table, but still we have very less records in this, so we don't need to worry about it. Okay, so this is something that is doable to forcefully use this index. Okay. Now let's discuss about the partitioning. As we know, real partition came from version 10.0, right? In Postgres, previously they used to do a native partition, which is trigger based or inheritance partition. Okay, it will be work based on some triggers. Okay, but now actually from version 10, actually real partitioning came into picture. So how we can create the partitions? Basically, we have to create a table and we have to pick the column, which is called as a partition key. Okay. So based on that partition key, when we create a partition table separately, actually based on some ranges, so the data will go and fit into appropriate range based on the data which we have defined. Okay, for example, I want to create a range partition. So range partition basically, and at what scenarios it will be used. So if you want to, divide the range of data with a timestamp. For example, you want to store some 2023 January to 2023 Feb, okay, in one partition, something like this, okay, with the timestamp, we can use that. Okay, let me create a table. For example, I have a sales table, okay. So in the sales table, I have some set of columns and I have choose partition by range, okay, on this column, sales data. So for example, I have this sales date, right? This is the column. Okay, it has a primary key and I'm going to choose this column as my partitioning. Okay, based on this column only, I will divide the ranges and I will create the partition. So usually in RP, what you do along with the table, yeah, along with the table, you will be defining the partitioning here, right? So here we have to create a separate partition table. For example, I'm going to create a one partition with on this table, something like this. Create table sales January. This is my partition table name. I have to create a separate table, something like this. Partition of sales. This is important. So on this table, you are going to create a child table called partition table. This is the range. Okay. So in similar way, I'm going to create for other month, maybe February. So for Feb, I will create this as this like this, and I will also create for March, something like this. Okay, this is a range partition, right? So Postgres, it supports range partition, list partition, and hash partition. Okay, so now if you do /d plus and this table, okay, this table having these columns, okay, and this is partition table, so it is showing partition key on this column. And if you see, it has automatically created an index because of the primary key. And this is the partitions which I have in this table. Okay. Even if you use /tt, you could also see it as a normal table, right? So we have sales February, sales Jan, and sales March. So these are part of this table, right? So you can just use /d and you can fetch the details of the partition tables as well. Now, whenever I'm trying to insert some data based on the range, for example, let me insert some data with January range. Okay, I'm trying to insert some data this range, right? So this is January range. It has to go and fit into which partition? January partition, right? So let me try to select the data, select star from. I'm trying to select from this table. This is the partition table of January. So it has go and fit into appropriate partition range, right? So if I just go and do select star from Feb, I don't have any data. In the same way, if I go and fetch from March, I don't have any data. You can also directly fetch from sales, which is your main table, right? So if you fetch the data from the main table, you will get all the data in all the partitions, right? So this is how it works in Postgres partitions. Now, when I try to insert the data out of range, okay, for example, let me take the same insert. I will go and try to insert in April. Okay, what it is telling? Partition, no partition of relation cells found for this row. Okay, partition key of the failing row contains. This is the thing. It is not able to fit because of we don't have range for April, right? So it will fail to insert. Okay. So basically, to avoid this, what in Oracle we have a concept called interval partition. So in interval partition, whenever you insert the data for the future partition data, it will also create the future partition automatically. But in Postgres, we don't have interval partition support, but we have extension called PG part one, where we can able to manage feature partitions with the PG part one. So that we'll see one example. Okay. So this is how it works. Now, let me insert two more records, which is within the range. Okay. So now I have 3 records, and each partition have single record. Okay, because of the range which I have inserted. This is how the range partition we can create, and we can create sub partitions and ranges. So your data will go and sit into appropriate partitions. Okay. Now, I want to select some data, for example, sales ID, product ID, and amount from sales where sales date greater than I will go with 01, for example. Okay, so this seems to be I need to convert explicitly with okay, something it is taking as a string. Okay, now for example, I want to fetch something data like this. Okay, let me take the execution plan, or maybe I will try to fetch something like this. Okay, so I have different values, and I'm trying to fetch the data. So let me take the execution plan. For example, for this query, I'm trying to take the execution plan. Okay, so if you see the execution plan, basically it is trying to go and search for the relevant partition, right? So it is not going and scanning all the partitions. If you see here, it is now currently based on this output, it is trying to go and fetch from the which partition? From the March partition. So it is only picking So it is going and picking only these partitions, okay, for fetching this data, right? So this is called partition pruning, right? It is not going and scanning for all the tables. So, I mean, all the tables means all the partition tables. It is directly going and fetching from the appropriate partitioning, right? So, for example, I have something called enable partitions. Okay, I have this parameter. Okay, sorry. Okay, by default, this parameter is on. Okay, which means your partition pruning is enabled. So you should not disable this. If you disable this, it will go and scan for all the tables. Okay, for example, I'm going to set this to off. Now let me take the execution plan. If you see the execution plan, it is trying to go and fetch January partition. It is trying to fetch February partition and March partition, right? So this is something not recommended to disable this this parameter. Okay, so we should always make it on. Because of this parameter, it is going and picking the appropriate partition base. This is called partition pruning. Okay, so which means your partition pruning will be work same like Oracle in Postgres based on this parameter. It will go and fetch the data appropriate partitioning. Okay. Now we'll see one example for list partition, how we can create a list partition basically. So basically, as we know, list partition is mainly used for if you want to categorize any data into distinct or grouping the data into sets, multiple sets. Okay. This is bestly suitable for any locations kind of data. If you want to group the data based on the location, if you want to store all the table data where location is India, it will store in one partition. You want to store in US, it will store in one partition, something like this. Okay. So I'm going to create a table called product here. And I have product ID, category. Okay. So category I have picked as my partition key, which means this is a list partition. Okay. You have to just mention which partition you want, whether you want range partition or list partition or hash partition. Okay. Now I will create a partition tables as well based on this uh, partition key. For example, I'm going to create a table called electronics partitions of products. Okay, the value in electronics. In similar way, I will create one more maybe for clothing or one more for furniture or something like this. So I created one more table for clothing and I'm trying to create one more for furniture. So I have three partitions created for this table product. Okay. Now if I see /dt products, I have this many columns and this is my partition key, and partition key will automatically have a primary key and it will create a index for this, and these are my partition tables. Now when you insert the data based on the category, which means based on the products, okay, it will directly go and fit into appropriate partition. For example, let me try to insert some data. If I want to insert and I want to insert with the category electronics, okay, it has to go and fit into electronics tables, right? So let's start from electronics. So it will go and fit into appropriate partition, right? Similar way, if I want to insert some table based on some clothing category, okay? So the data will go and fit into appropriate clothing table, right? So let's start from clothing. Similarly, if I try to insert some data furniture, okay, so it will go and fit into appropriate partition. Example here, this is the one, okay. So if you select your table, you have all the your table name. So this is our table name, okay. So we have all the data and this data is going and fitting into appropriate partition tables, and when you query that data, it will go and pick the partition pruning, okay, something like this. Similarly, similarly like how we have seen partition pruning previously, it will go and fetch the partition pruning as well. Okay. Now we have as discussed, we have a partition extension called PG Part 1 for better partition management. That is very important in Postgres. Okay, so many companies will use that extension. Even it is very useful or very important when you do a migration from Oracle to Postgres. If you have an interval partition in Oracle, okay, if you want to migrate those partitions into Postgres, so you will have a challenge because it will automate. Even first of all, interval partition will not support in Postgres, right? So you have to convert it into a range partition, and you have to manage with PG part 1. Okay, for example, PG part 1 is one of the external tool. Okay, let me install it. Mlist module PG part 1. Okay, this is the package. So even you have a Git repo, directly you can go and download the source code of PG part 1, and you can install it. Okay, with the help of make install command, you can directly install that package as well. Okay, and you can make it use of this PG part 1. Or if you have root access, if you take help from Unix team, they can install this package and I will give to you. As a DBA, we can install our extension. So let's install this PG part 1. We'll see how we can manage partitions with the help of PG part 1. So when you install this package, you will get the control files and all the extension files into your extension folder. Okay, so for your Postgres pandas, and then you can able to create your extension PG part 1. When you create this extension, you will get some set of inbuilt functions, tables, and procedures. Okay, so we can make it use of those functions, and we can able to manage the partitions. Let's see. So mainly this PG partment will help you for automatic future partitions. Okay, so with the help of PG partment and PG cron, two extensions, you can able to manage automatic partitions. It will automatically keep on creating the partitions based on your will show. Okay, one example how it does.
So one question is, when we do these upgrades, right? Other day you showed us the upgrades.
Mhm.
We have to make sure all these extensions that are installed,
Yes,
we
yes.
will have to install it for the newer version before
Correct.
we
Before we go, before we upgrade. Yes. So before we upgrade, actually we have to check the whatever the extensions which we have installed. Okay, so all should be compatible to the latest upgraded version, whatever we are going to configure, right? So first we need to upgrade those extensions, and then we have to go with upgrade. Otherwise, you may get conflicts after you upgrade. So now, for example,
in Postgres, do we have an option to drop these partitions as well? In one of the beautiful feature in Oracle is that you can drop the partitions to
you can directly drop your partition table. That's it. Drop table is simple.
Okay.
Yeah. So we can drop this partition table, and in Oracle, actually you can able to, if you want to purge the old data, or maybe you can actually drop the partition, or even you can do with the delete statement. If you don't want to drop everything in this partition, only some set of data with some range of data, right? So even here we can manage with we can directly drop a table, or even here we can also do it with the delete statement. but we also have PG part 1. With the help of PG part 1, we can easily, this partition table will automatically attach and deattach from the partitioning table. So that also we'll see one example.
Okay, sure.
Yeah, so now, let me see. Yeah. So now I have this database. Actually, if I want to see the list of partitions, what I have, these are the list of, sorry, not partitions. So the list of extensions, okay? So if you want to see the list of extensions, we have /tx. Now I'm trying to create the extension called pg underscore part1. Okay. So if you give /tx and if you want to know more information about this partition, so extension to manage partition table by time ID or ID. Okay. So if you see /tx plus pg part1, okay, it has the latest version, which is very good for us. Okay. So latest version have so many features. It has so many functions. Okay. And it has tables. Okay. This table is very important. So if you create any partition, it automatically, we have to make an entry into this table, okay, that you have created a partition. So you have to tell to the partman that you have created a partition. So that partman will take care of, PG partman will take care of maintaining everything. Okay. So we'll see one example. And we also have one important function called creates not subparent. We have create parent table. Okay, this one, create table function. So we can use this function and we can define the properties of the PG part 1, like whether you want a list partition or range partition or something, whether you need how many future partitions, how many previous, past partitions you want, retention, everything we can define on based on this function. So we'll see one example. Before we create any partition table, I want to load the libraries of the PG part 1. Okay, for this, I have to go to my parameter file. And as usual, we have a parameter called shared preload libraries, right? So for that, we have to, sorry, still in, okay, PG data. Yeah, so we have shared preload libraries. We already have pgedit log2 file. So let's add, so we also need to add pg part 1 VGW, okay, which is the background worker process, will take care of automatically creating these partitions and all, okay, based on the condition whatever we have. So we'll see one example. So I have to restart my cluster because of this parameter. Okay, so now okay, so what I will do, instead of my extension into the public schema, I will try to create a separate schema for better understanding. So drop extension. So I'm going to drop this extension for now. What I will do, I will try to create a schema called part1. Okay. And I will try to create this extension under this schema. Schema part1. Okay. This is always good practice. Now, if you see /dx, this partition is part of your part1 schema. So we have a separate schema because this part1 have so many functions tables, okay, that will store in a separate schema for now. So while creating this extension, you can also point out to any schema. And in this schema, you don't want to store any application kind of objects, okay? So we'll create a separate schema for application objects. Maybe what I will try to do is I will try to create a schema called part1 underscore test. This is my application schema. So I will make all these objects into this schema, okay? For example, I'm trying to create a table, okay? So I'm trying to create a table called part1 test dot time time test table. Okay, this is my table name, and I have 3 columns. Okay, and partition by range. So I'm going to create my partition range partition on this column. Okay, so you have to just create a main table with the partition, and then now we are going to update this table to the partman. We are not going to create any partition tables. So all the partition tables will be automatically created by partman. Okay, so for this we have, as discussed, we have a function called create parent. Okay, before that, let me create an index on this particular column. Okay, so I'm going to create an index on this column. Now, before I create the partitions, if I just use /d plus, currently there is no partitions available, right? So because I haven't created any partition table, I just created the main table and I have just defined the partition type. This is the range partition on this particular column. Now, since I have PG part1 extension, I will update to the part1 that I have this table. This is my parent table, and you have to create some set of partitions based on the value which I have defined. Okay, it may be feature partition, it may be the old partitions. Okay, so by default, part1 will create 4 partitions: feature partition 4 and past partition 4. Total it will create 9. Okay, with the current. So we'll see one example. So for example, I am making the use of the function create parent. Okay, so create parent is this is a function which is a part of your extension. So this, in this schema, I have this parent, this create parent function, right? In this function, I'm passing the arguments. You know, right, how to execute the function. So function can be executed with the select statement as well, even in Oracle also, right? Even in Postgres also, we can use the select statement. I'm calling this function. This is the arguments which I'm passing. So parent table is part1 test dot. This is my parent table, and this is the partition key. Okay, so on which column you are going to create the partitions. So this is the partition key, and here interval partition, I'm going to create day wise partition. Okay, so I'm just calling this arguments here. Okay, now when you call this function, these entries will be automatically entries in the table called part_config. Let me see what is the table. Okay, so part1 dot pg_. Okay, currently we have executed this table, right? So this function create parent, when you pass the arguments, it will make an entry into this table part.config. So we'll see this table as well. Okay, before that, let me /d plus. Okay, I have to move to this schema, right? Because we have created the partition table into this schema. Set such_part equal to. Now, these are the tables I have. Okay, this is the main table, right? So if you see, it has automatically created these partitions. Actually, we haven't created any partitions, right? So part1 has been created. Previously, we have seen 0 partitions. Now, totally it has created 9 partitions. So this is the current time stamp in my system. Okay, this is the wrong time. This is not the current time. If you give select now, like select sys date from dual, same command. So the current date is 15th of April right now in my system. This is wrong time, don't worry, but the current timestamp is this one. If you see, for this timestamp, previously it has created 4 partitions, and after also it has created 4 partitions, right? So totally it has created 9 partitions. This is the default partitions which it creates, okay? But if you want still more partitions, you have something called pre-make. You can define that pre-make value and make it create like how many partitions you want. For example, 100 partitions. You can just make you can just pass an argument like pre-make value is 100, something like this. So it will automatically create the 100 partitions, future 100 partitions, past 100 partitions. Okay. So part 1 will create these partitions. This is the naming conventions with which it has created the partitions. Okay. Now, for example, if whenever you create this partition, whenever you pass this function, okay, it will automatically create this number of partitions, and it will also make an entry in the table called part_config, which I have explained you, right? So for example, I want to see the entries. So let's start from part1.part_config table. So let me display properly. If you see in this table, okay, this is my parent table, and this is the column. On this column only we have created the partitions, right? And interval means 1 day. Every one, it is a day-wise partition. Even you can go with monthly-wise, yearly-wise partitions as well, okay? And this is a range partition. Pre-make value, this is the thing which I'm talking about. By default, it is 4, which means it will create future partition 4 and the past partition 4. If you change this value when you are when you are passing the arguments to this function here, what we did, there is the select statement. Yeah, this one. Here you can also pass one more argument called pre-make to 100. It will create 100 future partitions and 100 previous partitions. For now, still, since I haven't passed this argument, the default value is 4. That is the reason for me I get total 9 partitions. On the current partition, it will create future 4 partitions and the past, total 9. Okay. And now it automatically creates a template table for us. Okay, this is the template table name. And if you see the retention, okay, so we can also make a retention value for this table to purge your old partitions. For example, you have 10 years of partitions. You don't want the 5 years part. I only want 5 years partitions. Okay, I don't want the data previously of 5 years. So in this case, you can also define the retention period. Okay, for now, retention I haven't set. That is the reason it is showing null. Okay, you can set the retention period. These partitions will be automatically detached from the main table, which means it is going to drop the previous partitions based on this retention value which we have defined. So for example, let me fetch the data. Retention value currently, let me make it off. By default, pre-make value is 4. Retention is nothing. I haven't set any retention, right? When I'm passing the function, create parent function. Now, if I want to, set the retention period for this particular table, so I can also use the update statement. So update part_config, because this is the table which it makes an entry, PG part1, okay? I'm making the retention as 3 days. Now, if I select the data, select statement, I have 3 days retention, right? Now let me fetch select start from Potman. Now it has updated my retention as 3 days, right? So after 3 days, automatically my partitions will get detached. Okay, this is one thing which is very easy. In Potman, we can manage all the partitions very easily. Even if we create automatically future partitions. So we'll see one example. For now, let me fetch /d plus. Okay, currently this is my table and this many partitions I have. If you observe one more thing, you also have a default partition. If you are trying to insert any data which is not part of this range, okay, whatever the partition ranges you have, you are going to insert beyond these partitions, it will directly go and fit into the default partition. Okay, so this is one more thing which is managed by Potman. Okay, for example, I want to insert some data. Let me insert some data. So let me take the range of 18th. So let me prepare an insert statement, and this insert statement is going to fit into this partition. Based on this range only, I'm trying to create an insert statement. Okay. insert into these values. Okay. And I'm going to insert this range, which is 18th of April. Okay. It has to go and fit into this partition, right? We'll see. Now, let me select the partitions. This is my partition name of 18th. So my data has fit into the correct partition. Now, if I go and fetch the select statement from here, no rows, right? Because my range is fit into this partition, so it gonna go and store into this partition table. Now, I have another function called maintenance function. Okay, that is very important. So let me, before I run the maintenance, I have the data from 11th, right? So 11, 12, 13, 14, 15, up to 19 of April, because this is a day-wise partition. Now I have inserted the record into this partition, right? So when you insert this partition, actually based on the pre-make value, it will automatically creates a new feature partitions. Okay, for example, let me call this maintenance function. Okay, this is very important function. Run maintenance program. What this function will do? So based on the data which you have inserted, okay, for example, in my case, I have inserted in this partition, right? It creates the feature partitions. Okay, automatically it creates the feature partitions, and it also delete the old partitions based on the retention which you have specified in that function. So for example, I'm just calling this run maintenance proc. So now we are calling this manually, right? You can able to schedule this automatically to run every half an hour or every 1 hour. Okay, so that this function will automatically create your feature partitions, and it will automatically delete your previous partitions. Now let me fetch the data. So if you observe one thing, the 11 partition has deleted, right? Why? Because your retention is 3 days, right? So, and it automatically creates the feature partitions, 4 feature partitions, right? Or 3 feature partitions, right? Who does this all things? Your maintenance function. Okay. So previously, if you see the partitions which we have from 11th, right? So currently, this is the date of my system, right? So what is the date of my system? Yeah, it is 15. Okay, so if you go here, currently 15th is my system date. Okay, so my retention is 3 days. It will only keep the 3 days partitions data, and it has deleted this partition because in my retention I have mentioned 3 days, right? So it has deleted this partition right now. And my current data is on 18th, right? It also creates the future partitions, right? I have 19th already. So it does create 20, 21, 22 here. If you see, it automatically create 20, 21, 22 partitions. Right? We haven't created any future partitions. This function, maintenance function, will automatically create the new partitions and delete the old partitions. Okay. So while creating the future partitions, your data has to be fit into at least the pre-make value, at least the previous 4 partitions range. Okay. Then only it will create the new feature partitions automatically. So that is the reason if you keep this maintenance job, if you keep this maintenance job every half an hour or maybe every 1 hour, so all the feature partitions will be created automatically, and whatever the retention period which you have specified, it will automatically delete or deattach your partition tables from the main table. Okay, so this is very easy for in Postgres database. This PG part1 is very useful extension, and we can make it use of while migrating your Oracle so your Oracle tables into Postgres, this partition is very useful. Okay, so it automatically creates the feature partitions and deattach it from this with the help of this maintenance function. Okay, this all functions and tables will come as a part of your extensions. Okay, so this is how you can manage. Any questions in this or any confusions?
No, Suresh, I don't know.
Okay. So actually we'll share the, lab manual regarding this part man. Okay, even we'll see some scenarios when we do the migration classes, okay, from Oracle to Postgres migration sessions. We'll see few of the scenarios, how we can, migrate these interval partitions into your Postgres partitions with the help of PG Partman. So we'll see how we can manage. So this is how you can create the table, main table, and you can update to the function that how many feature partitions you want based on the pre-make value. It will automatically create the feature partitions, and you can also specify your retention period for this partition, and you want a day partition or you want a, yearly partition. You can define that all the partition. Okay. So yeah, this is about the partman and partitioning in Postgres. Okay, so probably we'll see tomorrow about this AWR kind of report and few of the data extract and import options we have when any application team wants to fetch the data or when they will give you CSV format how you want to import into a table with better performance. That scenarios we'll see tomorrow, followed by AWR kind of report how we can generate. Okay, so today this is about the partitioning. If you have any questions, please feel free to ask regarding these partitions. Okay, if you don't have any questions, probably we can catch up tomorrow for the remaining stuff. Okay, then thank you.
Okay, thank you.
Thank you.